The lexical analysis engine operates as a stateless token generation subsystem responsible for converting raw character streams into normalized token sequences. Input streams are processed sequentially without buffering beyond the immediate look-ahead window. The engine maintains internal state limited to current position, token boundary markers, and recognition automaton state. All operations complete in linear time relative to input length. Token classification occurs deterministically based on pattern matching rules evaluated in lexicographic order. Token recognition operates through a series of ordered pattern matchers. Each matcher examines the current input position against its defined pattern set. Pattern matching begins with the longest registered patterns and proceeds to single character tokens. When a pattern matches, the corresponding token type is assigned and the input cursor advances by the matched length. Unmatched character sequences trigger error tokens with diagnostic position information preserved for later analysis. Whitespace handling is controlled through the whitespace mode configuration parameter. When set to preserve mode, whitespace characters generate explicit token entries preserving exact spacing and indentation. The collapse mode combines consecutive whitespace into single separator tokens. The ignore mode advances the input position without generating tokens. New line characters are tracked separately in all modes to maintain accurate line number tracking for diagnostics. Tab width defaults to 4 spaces. Comment recognition follows whitespace processing in the pipeline. Comment patterns are defined through a tuple of opening and closing delimiters. Single-line comments extend from the opening delimiter to the next new line character. Block comments require explicit closing delimiters and may span multiple lines. Nested comment handling is optional and configurable per pattern. The engine tracks comment nesting depth to prevent premature termination on nested opening sequences. String literal recognition is performed through delimiter-bounded pattern matching. String opening delimiters trigger entry into a dedicated string parsing mode. Within string mode, character processing follows escape sequence rules defined in the string escape table. Recognized escape sequences are converted to their corresponding character values. Unrecognized escape sequences are either preserved as literal pairs or trigger error tokens, depending on the strict escape mode setting. Identifier tokenization begins when the input encounters characters matching the identifier start set. Subsequent characters must match the identifier continue set. The lexer accumulates these characters until a character outside identifier continue set is encountered. The accumulated sequence is checked against the reserved keyword table. If a match occurs, the token receives its corresponding keyword type. Otherwise, the token is classified as a generic identifier. Numeric literal recognition applies different pattern matching rules based on the numeric prefix. The lexer first attempts to match against prefix patterns like 0x for hexadecimal or 0b for binary notation. When a prefix matches, the subsequent digit matching follows the base-specific alphabet. Decimal numbers process digits 0 through 9. Underscore characters may appear between digits for readability and are stripped during value conversion. Operator token recognition occurs through a trie-based pattern matching structure. The trie is ordered by length with longest patterns examined first to prevent premature matching. For example, the 3-character operator becomes checked before the 2-character equivalent. Single-character operators form leaf nodes. The matching process descends the trie based on successive input characters, backtracking to the longest successful match when no further progress occurs. Position tracking maintains precise source coordinates for all generated tokens. The position struct contains the line number, column number, and absolute character offset. Line numbers begin at 1. Column numbers begin at 1 and reset after each new line. The absolute offset begins at 0 and never resets. Position information is attached to every token for diagnostic reporting. Error messages reference line and column numbers for user clarity. The token emit operation appends a new token to the output sequence. Each token contains its assigned type, literal text span, starting position, and metadata tags. The emit operation is atomic with respect to the lexer state. No partial tokens are ever emitted. Failed pattern matches result in error tokens with type error and position information preserved. The lexer continues processing from the next character regardless of error tokens. Error recovery mechanisms are passive by default. When the lexer encounters unrecognized characters, it generates error tokens and advances by 1 character position. No attempt is made to resynchronize or skip ahead. The downstream parser is responsible for error recovery decisions. Optional strict mode may terminate lexing immediately upon error token generation. Diagnostic mode preserves all error context including surrounding character sequences for detailed reporting. Configuration is provided through the Lexer configuration struct. The keyword table contains language-specific reserved words mapped to their token types. The operator table defines all recognized operator tokens and their precedents. Pattern matchers list all custom pattern rules. Character classes define identifier start and continuation sets. All configuration is immutable after engine initialization. Configuration changes require creating a new engine instance. The lookahead mechanism maintains a circular buffer of previously matched input. The buffer size defaults to 32 characters. Lookahead retrieval at position n returns the character at absolute offset n from the start. Out-of-bounds lookups return the null terminator character. The lookahead buffer is advanced incrementally as the cursor progresses. Historical lookahead data is discarded once the cursor advances beyond retrievable range. Performance characteristics are linear in input length. No quadratic behavior occurs under any input condition. Memory usage scales with configuration, size plus lookahead buffer. Token output memory grows proportionally with token count. Typical lexing rates on commodity hardware process approximately 5 million characters per second. Input buffering defaults to 64 kilobyte blocks for file input. Streaming mode processes single characters on demand. Thread safety guarantees apply to immutable Lexer configurations. Multiple threads may share a single configured engine instance for read-only lexing. Mutable operations such as configuration modification are not thread-safe. Each thread requiring independent lexing state must create its own engine instance. Token output sequences are inherently single-threaded by construction. Concurrent invocation against shared output is undefined behavior. The Lexer lifecycle begins with engine construction and configuration binding. Lexing operations commence when input is provided through the process method. The engine processes until input exhaustion or termination request. The output token sequence is retrieved through the tokens method. The engine remains reusable after completion. Subsequent invocations begin lexing fresh input against the same configuration. Resource cleanup occurs on engine destruction.